Hey guys, in our previous video we discussed about this remove method and we tested our code and our code seemed to work fine. Now we are going to add some more methods and they're going to be the small ones, not as complicated as remove methods, right? So the method which we are going to include this time is find. So we made binary search tree. So we have to add a method which searches for our data, right? So we are going to provide data as an argument. Okay. So if self dot root. So this function will work only if the self dot root is true or the root node exists, right? So return self dot and double underscore find data and self dot root. So we are telling this method find and let's just add this to make it look different. So we are telling this find data method to take this data and take this node and look for the data in traversing throughout the nodes and tell us if the node exists or not, the node which contains our data. And for now we are removing this return statement. Okay, just to tell you all that what will happen if we don't add the remove statement. Okay, so define find data and it takes data and node. Okay, so first we have to look for the data, right? So first we look for the data. Okay, and if data is smaller than node dot left, oh sorry, node dot data, if node dot left, then return self dot uh, find data and this time data and node dot left. Okay, now similarly we have to look for if we are going to use the elif statement. If data is greater than nodes data, if node dot right, so we are telling the code that if there is a node right node to the current node, look in that right tree, right? So again we are going to return self dot find data. We are going to pass data and node dot right. Right, now elif data meets nodes data. Oh, this small mistake. Okay. Return true, else return false. So if we find the data, it is going to return true. Okay, so let's just check our code. Let's try to find 10. Okay, so we are going to print tree dot find 10. Now let us run the code and see what happens. It says none. This is why we have to use the written statement. See, here, because by default this method doesn't know what to return, right? So even though this function is returning something, but ultimately the last call will go towards this method, because this is where we first called the find data method, right? And that is why we have to use the return statement, so that finally the find method, the original find method, can return something. Okay, so now as we have added the return statement, it says true, and if we look for 100, it should say false, correct? What if we uh, pass a string? Okay, so this gives an error, right? So we can always handle the exceptions, right? So to solve this problem, all we have to do is insert a try, then indent these two lines, and we have to insert an except block, which accepts the type error, and it returns uh, incorrect data. Okay. Uh, and if we run our code, it says incorrect data, because the error is being generated here as we have passed a non-integer value. So it's going to catch this type error, and then it's going to return the incorrect data. So that is how we find our data in our uh, binary search tree. So now let's define some more methods. So define minimum and return find minimum data and self dot root. So we forgot to add one statement. If self dot root exists, right? Self dot. And now we have to define find minimum. It is going to take data as well as the node. We have to do the same thing which we did in our find, So this time, this is how we are going to approach, to find the minimum value. So to find a minimum value in a tree, we want to look for the leftmost node, right? So the leftmost node will contain the smallest value. So if node dot left return self dot underscore find minimum, and we have to pass node dot left, and finally return node dot data. We are returning the data, right? Okay. Oh, we don't have to use this data thing, right? Okay. So our minimum method is ready, and now we have to make two more methods. Define max, and it is going to return self dot find max, the internal private method. It is going to have self dot root, and before this if self dot root. exists, and we indent this. Now we have to make define find max. Okay, and we are gonna pass some node. If node dot right. Now to find the largest value in our tree, we have to look for the rightmost node, because the rightmost node is going to contain the largest value in our tree. So again, we are going to use the return statement and recursively call this function find max, and this time node dot right. Okay, so that is how we are going to uh, you know travel across all across our tree and find the rightmost node. Okay, so I think it's done. All right, so we don't have to use this data variable here, and we are done with our minimum and maximum methods. So let's just check it. So here we are going to use print tree dot minimum, and we are going to add a little statement here, minimum, so that we know that this is the minimum value, and similarly print max and tree dot max. Oh shit, I think we made some mistake. Oh, we forgot to add the parenthesis, and we forgot to add the data here. Now it's going to work fine. So the minimum is -6 and maximum is 24. So yeah, we're done with our binary search tree, and we have made all the crucial methods: the insert, remove, traverse, and finding our data, the minimum and the maximum in the tree. Okay, so see you in my upcoming videos. Thank you.